Okay, so here we've got, I think, quite a typical GCSE exam question, which is asking us to calculate the average speed of a car in part A, given that we've got these two snapshots here, and we've got the time, so we've got distance from these two snapshots, the distance the car's travelled between two points, and we've got the time that it took to travel this distance. Okay, so that should allow us to calculate the speed. In part B, we've got a conversion problem, so we've got 1 kilometre is 1,000 metres. Well, I think we knew that, but maybe we didn't know that 1 hour equals 3,600 seconds, which is 60 times 60 as we're converting from hours to minutes to seconds. So 60 times 60, 3,600 seconds. Okay, so we've got a conversion problem in part B. We're told that a lorry is travelling at this speed here. We've got to show that its speed is less than 50 kilometres per hour. Okay, well, let's have a look at the examiner's remarks and see how people did. And there's quite a few things to learn from this, because this was a question, in fact, that appeared on two papers. It appeared on the lower level paper, the foundation paper, and it also appeared in the early part of the higher paper. So we've got quite a lot to learn from this. So for the foundation students, apparently both parts weren't well answered. Part B was the least attempted question on the paper. Common errors were to multiply distance by time and not knowing how to divide by 0.5, so dividing by a half. So that's something we'll pick up in a moment. The most common error in part B was in changing the 13.6 metres per second to kilometres per hour. Apparently many students just did it like this, 13.6 times 1,000 or 13.6 times 3,600, whereas they need to use both of these to get the correct answer. Now in the higher tier, for the higher students, part A was apparently a very good discriminator. The common error was to use an incorrect distance travelled. So unfortunately people didn't add up the distance correctly, so that was a problem. In part B, responses were mixed. Students converting, though, from 13.6 metres per second to kilometres per hour, straightforwardly converting up, as it were, they did tend to be more successful than those working from 50 kilometres per hour or attempting to convert both to metres per hour. So there were some sort of complicated things that were seen there, which just sounds like overcomplicated the problem. So we're just going to straightforwardly go from meters per second to kilometers per hour. All right, so let's see how we can solve this problem then. So first of all, the speed camera. The first thing that we need to do perhaps is remind ourselves what the formula is for speed. Well, speed, as hopefully you know, is distance over time. And the distance, well, if we look at the front of the bumper here to the front here, the distance is going to be the number of intervals times the distance of the intervals, or between each of these points here. So it's 0.6, so it's 0.6 times how many intervals there are. So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, or counting backwards in twos to make sure. 2, 4, 6, 8, and another is 9. So very carefully writing that down. 0.6 times 9. That's the distance done. Now the time is 0.5 seconds, so half a second. So we could write half, but since we've got a decimal already, we'll write 0.5. Okay, now 0.6 times 9 is going to be 5.4, so 6 times 9 is 54, so 0.6 times 9 is going to be 5.4. Okay, so that gives us 5.4 divided by 0.5. And you could struggle with the idea of dividing by 0.5 or a half, but I think probably the simplest way of thinking about this is if you just think what I want. Well, what I want is a unit rate, so in other words per second, not per half a second, so I'm just going to double this part of the ratio, or the rate if you like, to 1. So if I've doubled the denominator, same to the numerator, so that's going to be 5.4 times 2, 10.8. Okay, so the answer, I'm going to put in the answer box here, is 10.8. But there is a nice easy way of checking, so let's just get the check done as well at the same time. So if I check using a slightly different method, instead of multiplying first, which is what I did here, I can divide. So I can say, well, 0.5 is a half, and a half, 9 divided by a half, that's going to be the, that's going to be the easiest. So 0.6, we could do 9 divided by a half, but I'm going to do 0.6 divided by a half is 0.6 times 2. So as long as you're familiar with dividing by fractions, you should realize that we now invert it and say this is the same as 0.6 times 2. I'm going to write that down. 0.6 divided by a half equals 0.6 times, and then just invert the fraction, 2 over 1 or 2. So that's going to be 1.2. So we've got now 1.2 times 9, and 1.2 times 9 is going to be, well, if you think of 9 times 12 to start with here, I'm going to use, let's use the crisscross method because it's nice and quick. So 2 times 9 is 18. That's the first step. Carry the 1. And then we've got 1 times 9. We don't need to do the 0 times 2. Plus 1 is 10. So 108. But because when I put my decimal point back in, I've divided by 10, I'm going to divide this by 10. Put my decimal point in there. So that confirms this answer, and this answer must be correct. Okay, so a little bit of written arithmetic there. Of course, if you've got a calculator, you can do a calculator check as well. So a lorry is travelling at 13.6 meters per second for part B. So let's write 13.6 meters for every second. Now, I've got to be very careful here, as we saw in the examiner's remarks, not to do this incorrectly. So 13.6 meters is how many kilometers? Well, 13.6 meters, the number of kilometers is going to be it's going to be a fraction. So I'm going to be dividing by this 1,000. So if I actually write here, divide by 1,000 to start with, that should keep everything nice and neat, and make sure, in other words, I won't make a mistake, hopefully. So very important to write things down as you think about them. Now let's move on to the other part of the problem, which is this idea of seconds. Well, if the car, or lorry rather, is travelling a certain distance in a certain number of seconds, then in hours it's going to, in an hour, it's going to travel an awful lot more. So I'm going to be multiplying up by this 3,600. So I'm going to have 13.6 multiplied by 3,600, or 3,600, which means now, as I've got this here, I can cancel quite a few zeros to make this a lot easier straight away. 1, 2, 1, 2. So dividing the numerator and denominator by 100 then. Now I think I'll keep going because I've only got 10 at the bottom here. If I cross off this 0, in other words divide the denominator by another 10, I can actually change one of these, and I think I'm going to just change the one that's already got a decimal in it. So divide that by 10, and of course I've got to make it smaller, so I've got now 1.36. Alright, so now again I've got a multiplication problem. So I'm going to again go over to one side here. I've got 136 times 36, and since we're practicing crisscross method, let's have a go at that. So 6 times 6 is 36, carry the 3. 3 times 6 is 18, and 3 times 6 is 18, so 2 18s are 36, plus the 3, 39, so carry 3 again. And now we're going to, with the third step of the crisscross method, we're going to crisscross like this and crisscross up and down. Well, I've got a 0 here, so that one doesn't count. 1 times 6 is 6, and 3 times 3 is 9, so I've got 9 add 6, which is 15, plus my 3, 18. So 8, carry 1. And now, for the next step of crisscross method, you just go into the middle here. So we're going to multiply, not into the middle, into the next crisscross area, if you like. 1 times 3 is 3, and this doesn't count, so 0 times 3 we're not going to add. So 1 times 3 is 3, plus the 1 gives me 4. So hopefully you're familiar with the crisscross method. If not, use the standard algorithm. But I find with the standard algorithm, this carrying, we do much more carrying, and that tends to get in the way. Can cause mistakes. Anyway, we've got 4,896, but we're going to put in our decimal point again. In other words, we're going to divide by 100, so that goes in there. So we're going to divide the answer by 100 as well. So that gives us an answer of 48.96 kilometers per hour. And so I think we've shown here by our calculation, therefore, that the lorry travels at less than 50 kilometers per hour.